So, hello everyone. I'm going to present myself. I am Mezzi Houssem, AI technical lead. Also, I am a learning content creator. I have a YouTube channel called Technology. I am an open source contributor. I've an open source organization called Al Hadiq Mind for people who know Arabic, so they know what's the meaning of Al Hadiq. And also, I am an organizer in Google developer community, two of them, Bizert and Beja. So I would like to thank all the organizers of this event, and also I'm going to thank you all for your patience for those 10 minutes to start. So I'm going to start directly. So our main talk will be about fine-tuning Gemma with Keras and LoRA using a custom dataset. I think the added value in this talk will be the custom dataset, because I believe that the most of tutorials or resources that we have right now, most of them use existing datasets, but I believe that for you, the main purpose or the first step for fine-tuning LLMs is to create your own dataset. So I will try to go to the theory a little bit. After that, we will go to a demo and show you how you can create your own dataset and also evaluate your model. Okay, so I'm going to start with the overview of what is fine-tuning. So the big picture of fine-tuning and why we need fine-tuning. And also I have a lot of examples using anime. So for people who watch Naruto, Jujutsu Kaisen, or those kind of anime, so they will try to, I believe they will understand more, but even if you didn't watch them, so it's okay. So I'm trying also always to give examples, funny them, etc., in order to simplify things. So the big picture of fine-tuning. Okay, let's start by why we fine-tune, and after that, we will explain what is fine-tuning. In general, LLMs performing very well with the most of tasks, but what about having specific tasks that LLM cannot perform well? Like, I don't know, maybe your company using a special framework, or using, they have, I don't know, anything that is special and LLMs was not trained on it. Or you want to evaluate, or not evaluate, maybe push the model or push the performance of a model in a specific task. So in that case, fine-tuning is the best option for you to answer this problem. So in fine-tuning, what we have the pre-trained model. So as I said, he's the genius who know everything, but nothing specific. Like Gemma models, they have big capabilities, but we can't say they are specialized in something. Even Gemma, they have many families, many versions, like Gemma, Gemma, etc. They are specialized, but we don't have for each task a specialized model. So if you want your specialized model, you have to go with the fine-tuning. Okay, so I'm going to skip some of examples, so because I know not every people watch anime. So when I should perform fine-tuning, as I said, if you wanna style, persona adaptation, formal completeness, domain specialization, if Gemma models, they're not trained on specific domain, etc. So I believe you will read slides after that, because I can't go into all details since I have only 30 minutes. But as I said, in general, when your model can't perform enough in your specific tasks, or they don't have enough knowledge in a specific thing, you need to go with the fine-tuning. Okay, what's the strategy? How we can do that? Of course, you ask yourself the first question, do I need fine-tuning? Because fine-tuning is like, I don't want to say it's complex task, but it requires more knowledge and more efforts and need a lot of time. So we don't go to fine-tuning unless we need it. Okay, so I believe this is the first step. You need to ensure that the fine-tuning is the only option for you. Second, we go to data preparation. I will talk about it, I think, later in details in the demo. Model and strategy selection, I think this is all those parts are important, because if you're going like fine-tuning your model in medical stuff, so you will go to fine-tune Gemma and not Gemma. Okay, so choosing your model is like a critical step for you in order to leverage a good performance. And finally, I believe experiments and evaluation. So you need to evaluate your model to know if the fine-tune you did is good or no. Okay, so we have two types of fine-tuning. So we can go with instruction fine-tuning or preference fine-tuning. In general, we go with instruction fine-tuning is the most popular, and you give more example, more performance, and as I said, more examples you can find and give the best performance until now. So the idea of instruction fine-tuning, you give the prompt and the model give you the response. That's it. But in preference tuning, you will have the prompts, you will have the chosen response and rejected response. So it's more like the model will learn to choose the best response, or not the best, the correct response, whether it's correct or whether it's not correct. The other one, it will get the prompt and give you directly the response. So I believe that preference fine-tuning have like specific tasks for him, but the more general one is instruction fine-tuning. Okay, so in the fine-tuning, we can go with two things. We can full fine-tune, or we can apply one of the techniques that we have. The most popular one is BEFT, parameter efficient fine-tuning. So whether we go to fine-tune the whole model with all parameters, or we can go with some techniques like BEFT, LoRA, and we get not the whole model, but a part of it. Why? I believe I'm not going to with this one. You will need fine-tune them and expert. I believe we explained this one. So why and when we go with the full fine-tune and when we go with the parameter efficient, I will say full fine-tune is like not the best option at all, because you will need to update all parameters. This is the first thing. And when we update all parameters, the model will have like a catastrophic forget. So basically, you will play with the whole model, and the model can lose all his capabilities, but he will be specialized in that one. So we go with the fine-tune. If we don't care about all the capabilities, and we want a version that know only the specific task, okay? But why we don't go, why it's not the best option, because it requires a lot of resources. It's not easy to fine-tune the whole model, because it's required to have like multiple GPUs or a very big server in the cloud in order to do that. So that's why we don't go with the full fine-tune, and we go with the parameter efficient fine-tuning. So the parameter efficient, we will explain it later. Let's go to not waste our time. The Gemma models. So now, as the talk I'm doing right now, we have the Gemma 3. Maybe later you will have Gemma 4, 5, etc. So the list, what we have now, we have very small one, 270 million. We have Gemma 3, 1 billion, 4 billion, 12 billion, and 27 billion. So in general, those are the models that we have that we can fine-tune. Of course, we have another for audio, etc. And we have the family, as I said, Gemma, Gemma, etc. It's not our talk to talk about them right now, but in general, even Gemma is a version of the 4 billion. So what Google did is like they took Gemma 3, for example, 4 billion, and trained it on medical stuff to create Gemma. So those are the base fundamental models. And your task, or your first task, is to choose which of the models you will fine-tune. And of course, like it depends on your task. So if you require a lot of reasoning, if it's really complex task, of course you will go with bigger models. And if it's an easy task, so you'll go with the small models, etc. So more parameters you have, more reasoning and more capabilities you have. It's an easy equation. Okay. So what I want to say after that is we have something that we call chat template. I don't know if you're familiar with it. I don't know that. So I will say that if you don't familiar with it, in general, models are fine-tuned in a specific chat template. So chat templates is like how we organize our prompts and our response. I believe I have a specific example. Okay, you can, I don't know if you can follow my mouse, but we have like start of turn. Like we have some keywords, start of turn, user. We put our prompts, end of turn, start of turn, model, end of turn. So it's like structuring our prompts and putting them in a specific structure. In general, we have system prompt, user prompt, and response or model response. But in Gemma 3, they don't have that. They only have user and model response. So if you want to integrate your system prompt, you need to concatenate it with the user prompt. So why I'm speaking about chat template? We will see that. I will explain it more in our demo, but in general, if you want to get the best performance, use the chat template of this specific model. So if you are going with Gemma, use chat template of Gemma. If you're fine-tuning Llama, use the chat template of Llama, etc. So using the chat template is like it's like how we say, if the model was fine-tuned on that chat template, so he will give you in general the best performance in that chat template. Okay, I hope it's clear. So I've just looked up about Gemma because we need them. Now we will go with Keras Hub. I believe most of them know Keras. I've started learning Keras like 2019. Since we fine-tune or not even fine-tune, train CNN, etc. So Keras like is one of the most popular and easiest framework ever made, and it's really high level. And we have Keras Hub, another framework built on Keras. Okay. So I believe I explained Keras Hub and Keras before diving into the slide. So as I said, Keras Hub is like pre-trained modeling library that is simple, flexible, as I said, etc., and built on Keras 3. And why we need Keras Hub? Like we import our models from Keras Hub, etc. For people who are using Hugging Face, it's similar to Hugging Face. Hugging Face imports models from Hugging Face, but Keras Hub imports models from Kaggle. So it's like the same thing. And even the fine-tuning, etc., we'll all do it with the Keras Hub. And the good thing in Keras Hub that it supports multi backends. So if you want to work with PyTorch, you just define the backend for the Keras Hub as PyTorch, JAX or TensorFlow. So it's like having the same code, but with multiple backends. So if you want to fine-tune with PyTorch, just select the backend as PyTorch. You don't need the code of fine-tuning with PyTorch. And if you want to move to test JAX, for example, you're not obliged to do another code from scratch. No, the same code, the same everything, just you need to change the backend to JAX. I believe I explained it all. As I said, it supports multiple backends, TensorFlow, JAX, and PyTorch. Same code, any backend. And maybe even if another framework will start soon, I believe Keras will integrate it. So Keras and Keras Hub, like those products are built to make things easier to developers. What are samplers? Okay, now we are getting to serious stuff. I don't know if you all know what inference is. So if we go like Gemini and we ask a question, this action called inference. If we do the same thing, but with Gemma models or the Gemini API, it's always same. We call it as inference, but the difference between them, when you go to the Gemini as a platform, there is no parameters. So you just write your prompt and get the response. But if we are going to work with the Gemini API, or specific like here, we are going to work with Gemma, there is some parameters that we are going to work with. I believe you know them, but if no, there is 3 parameters that you should know them. Just take notes: temperature, top end, and top key. So temperature is like the most famous one, because it's we can like control how we say it, the name in the randomness. Yeah, I'm sorry to forget this word. So we control the randomness of the model. If we want the model to be the more creative, and as I said, so we go with higher temperature. If you want him to be very specific or very precise, so we go with lower temperature, like coding, etc. So we go with low temperature. But if you want your model like to generate a poem for you, or text, etc., so I believe you want him to give you a creative one, so you give a higher temperature. And of course, the top end, the top P or the top K, also those are parameters that control the next token for you. I'm going just, I believe I explained them here, like top P, the random entry probability thresholds. Okay, I'm not. Okay, I think I'm obliged to explain it. So the top P like is a parameter. Like if I said the top P is 0.8, so we take tokens until we reach 0.8. Make this phrase for you. If you understand it, okay. If you don't, try to make some research for it, and I can share some resources with you for it. And the top key is like random from top key options. Like if I select key as 15, we will choose the next token from 15 token. I don't know if it's really explains, but in general, samplers are those parameters who control the next token. As always said, I think the basic definition of LLM, we know it, the large language model, and we know how it works. We know that LLMs predict the next token. So this prediction, since LLM is probabilist, so this prediction, we have some parameters that control this prediction. Those parameters, the most famous 3 of them, as I said, top P, top key, and the temperature. Okay, so those parameters are included in something we called samplers. Okay, hopefully it's easy for you to understand that. Okay, now we can go. Okay, so now I will explain briefly the samplers in Keras. Like we have many. We have the greedy samplers. Always go plus ultra. So what greedy sampler do is always pick the higher probability. Okay, so here, what's the issue of, okay, many people, okay, say, okay, this is the best one. Okay, we take the higher probability, but getting always the higher probability make your model not creative at all. Okay, so if you want a creativity, greedy sampler, it's not the best option for you. Beam sampler. Okay, beam sampler like is keep tracks of multiple possible sequences. It's like having this a strategy. Okay, like having multiple token and trying to find the best path or the best token for him. Okay, it's like I don't know. Maybe for people who watch anime, like Shikamaru, if he's in a war, so he take a moment, he saw what options he have to stay alive, and this is the same for beam sampler. So he choose the best strategy for him, and he have like parameters called non-beams, and with non-beams we control how many paths we explore. It's like if I ask him a question, he will answer in three different way if num beams is equal to 3, and if we want to simplify thing, he will answer it 3 times and or explore the answer 3 times and give the best one. Okay, so the consequence of this one is a little bit lower because he is obliged to explore many paths. As I said, it's like answering your question 3 times and he gets the best one. Okay, top key sampler, as I said, is the most famous one. In this, we control the top key, as simple as that. So as I said, top key is if key is 15 token, so we choose the next token from those 15. Top P integrates top key and the temperature, I think. It includes those kind of, I think, 2 or 3 parameters in that sampler. And of course, the top P is the main one. And the random sampler, the best creativity you ever have. So I will simplify this into this definition. And I believe this is the last one, yeah. Contrastive sampler, so no repeats. And for people who ever used, I don't know, Llama or LM Studio, Llama CPP, or even Hugging Face, we have a parameter there called repetition penalty. Okay, if like your model is like repeating a token or repeating a path or repeating something, we have a parameter we call repetition penalty. The same thing we have in Keras, and we choose the sampler contrastive one, and it will eliminate all those kind of repetition. Okay, just I'm trying to simplify in order to reach the demo. I don't know how much time I have left, so I'm trying to be quick as I can. Okay, for data preparation in general, the data should be in general system prompt, and the system prompt is the prompt or the instruction for your model. So it's necessary for fine-tuning and even in inference. Like if I say you are an expert in something and your job is to do this and this and this. So this is the system prompt. And we have the user prompt or the question or whatever it is. And it could be like generate a code to me, etc. And we have the response. We have 3 things. And as I said, for Gemma chat template, we only have user prompt. So we concatenate the system prompt with the user prompt. Okay. We go to Backbone and LoRA. I'm trying to simplify things because I believe that I have 25 minutes. I don't believe that I have 25 minutes. Okay. Okay, perfect. Low rank adaptation. So LoRA is the famous and the best technique to fine-tune LLM. So if I'm going to simplify without going with those math, etc., so I'm gonna say that LoRA. Okay, as I said, we have full fine-tune. We fine-tune the whole model. Okay, so the idea of LoRA. Okay, don't fine-tune the whole model. Go and fine-tune a part of this model. Okay, and then we merge that part with the existing model. You got me? So here we have the new W is the existing one with the LoRA one. And LoRA is like we have 2 metrics, which are, okay, you have here the blue one is our model, and we have the right side is LoRA. So the idea we took a part of this model, a specific, I don't know, it could be 10%, 15%, etc. of the model, and we fine-tune it. Okay. Then we merge that part with the original model and push. Here the magic is. So we will have a new model, the same size, the same everything, but with the new capabilities. So this is the best thing of LoRA. And the other side, that the model still have his other capabilities. Like if you fine-tune like your model with LoRA on Python, for example, the model still can generate code in C or Java, etc. Okay, but If you go with the full fine-tune and you full fine-tune model with Python coding, you have like a possibility, and I think that will happen to you, that your model will not generate C code for you. Okay, this is like from the general perspective of the difference between them. And we have, okay, we have two parameters, two main parameters, but in Keras Hub, like we go with only one, and is the rank, okay, the L rank. And as I said, LoRa will take a part of the model and fine tune it and then merge, okay? And as I said, this part could be 5%, 8%, 10%, etc. So this parameter control how big the part is, okay? So if R is 1, it's like having a very, 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 very small part of the model. So don't expect that after fine-tuning that you will have the best performance, okay? Only if the task is very, very simple, okay? And of course, don't go with very high R like parameter, because it's like going back to the full fine-tune. So I believe the main thing in LoRa fine-tuning is to find the best parameter for you, okay? So there is no magic trick here. So the main idea is just to maybe go with lower rank and go higher, higher, higher until finding the best one, and of course avoid overfitting. Okay, I'll skip this. I'll skip. This is how we define LoRa. For coding is the very, very, very easiest one. So don't ever care about coding. So just Gemma, backbone, enable LoRa, and we put the rank. It could be 8, 16, etc. So coding, it's not the issue here. I'm going to skip this. Sequence length. I believe we should know about the sequence length, because the sequences is an important parameter, because the more sequence length you have, the more resources you need. And the sequence length is the length of your prompt and your response, okay? The length of it. So the more you have, the more resources you need, okay? So try to choose the best sequence length for you. Optimizers, okay? So I believe most of you know optimizers. So in our case, I believe Adam is the most popular one with the weight decay. Okay, I'm not going through all parameters because we don't have like enough time. And I believe learning rates, those kind of parameters you all know. If no, you will still have those slides to know them. But learning rate control how far or how how far or how much the model will learn. In general, we take very low learning rates in order to go step by step into convergence. Okay, those are other parameters. I believe that for beginners, just keep them as default. Okay, compile, just we build and we finish our configuration for the fine tune. We specify our model, our optimizer, the loss, etc. The loss is the error. Okay, I'm going to simplify this as an error. We have mixed precision. Okay, I'm not going to go deeper in this part, but in general parameters, okay, the model like Gemma 1 billion parameter, 1 billion parameter. Okay, those parameters in general are written in 32 bits, okay, bytes. So in order to optimize training, we don't put the type as float 32. We can go as float 16 or mixed float 16. So just is a technique to optimize fine tuning. Okay, in order, it's like it's easy. Instead of writing the parameter in 32 bytes, we write it in only on 16, or even we can quantize it to be more, like 4 bytes, etc. Okay, so quantization is like very, very, very used right now. Fit, I believe Fit, you all know it. So here we train our model and we put all the needed parameters for us. I'm sorry to not go deeper in that because I have to finish. Popular callbacks, so model checkpoints, early stopping, all those kind of things is to help us avoid overfitting. So not to not let the model overfit on specific data. Okay, so how we save? I believe saving is the most easiest one. So it's just writing a specific code. You will find an example provided from Google how we full fine tune and how we fine tune with Buffed. And I will give you also my proposition. I have like a Medium article. Also, I have a notebook of how we fine tune with more details. So I will share it with you. And after fine tuning, I believe you need to deploy your model or test it, etc. So I'm just going quickly here with the famous inference engines. So it's like when you fine tune your model, you save it, you save your model. Now you have a saved model. How you're going to talk with him? So in general, we use those inference engines, Llama CPP, Olama, and LM Studio. Those Olama and LM Studio are based on Llama CPP. So Llama CPP is a very famous one who quantize model, as I said. So instead of talking with the LLM in 32 bytes parameter, we can go with 4-byte parameters. So like if the model is like 20 gigabytes, it could be simplified to 4 gigabytes. This kind of quantization is very, very, very useful now. So I recommend all of you, if you don't know what is quantization, to see what is it, and maybe test one of those three frameworks. We have Light RT LLM. I love this one from Google because it's like optimized for AI edge device. So if you have mobile phone, I don't know, Raspberry Pi, etc. So the core venture of Light RT-LM is to make your model optimized even for your phone, or even for your mobile phone. So if you're going to program your mobile application and you want a model that will run in your phone, so Light RT-LM is the best option for you. Okay, so and also you have the cloud solution, Google Model Garden. So it's the solution on Vertex AI that Google provides in order to enforce your model. And here you don't care about anything. So just you will have an API, you give you the prompt and you get the response. Evaluation metrics. So I believe we are in the end of the presentation, but I don't know if I have a quick time to show you a quick demo or no. So those metrics could help us in order to evaluate our model. Okay, so we have perplexity, blue, rouge, etc. So just the idea, we have the error. The error, what is the error? Is in general, we have our value and our predicted value with the original value, and like we take the difference between them. Okay, this is the basic formula of the error or of the loss. So we have other metrics like those one. What we give? We give the output of our model with a reference one or the corrected one, and we will have other metrics, not the error, but other metrics that give us if our model is near to the best response or no. Okay, so just I'm trying to simplify it as I can. So it's very important to you, well, when you fine tune your model, to test your model with those metrics and you see if the model is performing well or not. Okay. I believe I'm going to just with one example, BERT score, and he will give you the semantic similarity. So you will give him the generated one, the model that your model generated after fine tune, and a correct one, and he will give you the similarity. I think this is the easiest one. Okay. Human evaluation is the best. Okay. So the best evaluation you ever could do is to evaluate your model by yourself. Okay, so those metrics just will help you a little bit in your evaluation. And here is my notebook. Could you ping me if I still have like time or no. So here you will have the Medium article of fine-tuning Gemma. I fine-tuned Gemma on CPU, not even a GPU. And I believe it's like complete guide for you. So for me, it's the demo time, but I still don't know if I have enough time to go with the demo. Like maybe 5 minutes. Do I have 5 minutes? Any hint to go with the 5 minutes? If no hint, I'll go with another 5 minutes. Okay, so I go with another 5 minutes. I'm not going to take your time so far. I'm just going to show you how we can generate our data. And I think that's it. I'm not going to take more time for you. Just I need to run the application. Okay. Just okay. So this project I've made in you will have in my GitHub repository. You can get it, and the main purpose of this project is to let you generate your data in the easiest possible way. Okay, so you only need to upload like your documents, a PDF, a book, whatever it is. We go with pre-processing, and we have a split of that document. We have sections, and each section the content of it. And after that, you'll go, if you want to generate question and answer or only question. In our case, we go with question and answer. You select your provider. Okay, I need to set a provider. This tool supports Gemini, OpenAI, and even open source tools like LM Studio or Olama. So I've already configured Olama and LM Studio here. And briefly, you can write it helps you to generate your system prompt, or you can use the general one, the template one. And you go with parameters that I told you about. Of course, you need to choose your model. For here, I'm going to go with Gemma 1 billion. Okay, to make it quickly. And here the magic: you just click generate, and the generation starts. So the main idea here is to generate question and answer for each specific content. Okay, I'm going to wait LM Studio to load the model. It's not my purpose here, so I'm going to go through this link, but I think I can't go with it. Okay. Okay, LM Studio is not initialized, so I will go with Gemma 4 billion, and I will end the session in this one. Okay, I believe. Okay, LM Studio. Okay, Gemma 1 billion was not loaded. Okay, you see how it works. So we have the question and answer for each section. So you can get this data to fine-tune your model with it. So after it finished generation, you will have, as I said, your data ready. Okay. I believe that's it. And you can download it later as Excel, CSV, etc., and use it in the fine tune. I believe I explained it. So this part of data generation. So as you said, it's very easy. Okay, I think it's still generating. I know it's complete generation. So okay, I will generate it as an Excel file, and you will see the data generated correctly. Okay, so after that, I will recommend you to go with the demo that I created. Unfortunately, I don't have like enough time to go with it. I can show you the Medium article at least. So he explains all, I believe, step by step, and also with the tool of generation that I've already made. You will find it also on GitHub, so you will have the full fine tune. Okay, I need to verify. Okay, I don't think it's the best one to verify right now. So let me open it with copy link, and let me go here. Okay, and you will have your notebook here. Okay, so also you can open it with Collab and fine tune your model there. Okay, why it's opened like that? Okay, never mind. Let's open it here. Okay, so you can download this notebook and start fine-tuning. You need Kaggle AI keys in order to download model. Here we specify the backend. We import our libraries. Here we load our model. So here I loaded the smallest one. Here we specify, here I did some tests with different chat templates. You're not obliged to do that. Here we define our data. So it's like I've saved the generated data as CSV. You can have the same code, and we created a dictionary with the prompt and the response. Okay, we specified the rank and the sequence length, also the optimizer for us with the learning rate. We compiled, we did the configuration, and we started the fine tuning. As easy as that, and we put the data. As you see, it's like fine tuning in 10 lines of code. It's not really the hard part is coding. So I believe I've scrolled it. I'm sorry for that, because I believe I took almost. I have like 15 minutes overtime. So you have all those kind of resources in order to finish your job. And the good thing, the last thing I'm going to show you, the last one, in our repository, you will have other things. You will have the project of generator, and you have a project of model evaluator. I recommend you to test it. What it is, as you remember, the metrics that I showed you, like birds, rouge, blue, etc. So this tool evaluates the model for you. Okay, I recommend you to see this one. I don't know that I can't see any questions, or I can't see anything. So I'm going to thank you all. So for keeping with me, even I exceeded the time. I'm sorry for it. Hopefully you enjoyed this one, and see you in next talk. Thank you so much.